when I reach PhD, that is the optimal solution. I must have exact aim where to reach. So I want to repeat the steps until unless I'm going to include all the vertex. If I consider this one, which is the minimum weight I'm going to have the weight 1. So what is my tree now? Spanning tree, that is 0 to 1. Okay, from 1. Hello to all, a warm welcome to my new topic, that is greedy technique. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my today's session, I'm going to deal with greedy technique. In that, I'm going to deal with the Prim's algorithm. Anyway, dear student, we are going to study about greedy technique. So what is algorithm? Algorithm is nothing but the finite set of instruction used to solve the particular problem. Now, if I consider algorithm, I have the brute force technique, I have the divide and conquer technique, I have decrease and conquer technique, even I have greedy technique. Now, what is greedy technique? In greedy technique, my intention is to find the optimal solution. So what is the optimal solution? That's nothing but the best solution among all the possible solutions. So this greedy technique is also uses the concepts of divide and conquer technique is used to solve the problem. This greedy technique is a straightforward technique and it is mainly used to find the optimum solution. So solving optimization problem. So what is optimization problem? The problem that demands either maximum or minimum result. And here the intention is to find the optimal solution. So it's a simplest method and it's a straightforward approach. It's not an algorithm, it's a technique is used to find the optimal solution. The main function of this approach is that decision is taken based on the currently available information. So dear student, when I want to apply greedy technique, I want to have the spanning tree. Okay, so what is tree? What is spanning tree? We have to learn. Okay, fine. What is tree? If I have the graph, okay, if the graphs are represented in the form of trees, the graphs are represented in the form of tree. And what about spanning tree? See here, okay, think that this is my graph. This is nothing but my graph. Okay, fine. Then what about spanning tree? I must have all the vertices are connected. So I have one vertex, vertex 2 and vertex 3. How many vertices? 3 vertices and all are connected. Then what about spanning tree? If I consider vertex 1, 2 and 3. So this is called spanning tree. So all the vertex must be connected each other. Then okay, edge must be v minus 1. That's nothing but the 2. So how many vertex I have? I have 3 vertex. 3 minus 1, it is 2. So the spanning tree must satisfy the property that is all the vertex must be connected and the edge is nothing but it is v minus 1. Okay, now we apply greedy technique to find the optimal solution. Now see here, whatever the current information is present, the decision is made without worrying about the effect of the current decision in future. Okay, fine. See here, I have the spanning tree. Okay, fine. Now, I have the weight 3 and 5. So, vertex A, B and C. Suppose if I want to reach, that is from A to B, what is the weight? 3. And if I want to reach A to C, how I'll reach? That is by 5. So here, which one I'll consider now? That is the shortest weight, that is nothing but the minimum weight, that is 3. Okay, fine. So I'm not going to bother about future. Okay, whatever present I have, I'm going to take the decision. So what is the current decision I'm going to take? That is, I'm going to consider the smallest value, that is 3. So this technique is basically used to determine the feasible solution. So what is feasible solution? Okay, fine. Let me to consider one simple real-time example here. Think that, okay, you have completed second PUC. You have completed second PUC. Now you have the option to go with medical, engineering field, or you can go with non-engineering field. In the sense what? You can able to opt BA, BCom, BBA. Okay, fine. So after second PUC, if I have all the possibility, then it is feasible solution. So I have the solution. Either I can go with the non-technical course or medical course or technical course. Okay, fine. If I have the percentage that is more than 90% above, then I can go with medical field. If my percentage is above 80, then I can able to go with engineering field. If my percentage is only second class, that is above 50, then either I can go with BBA, BCom or BA. So dear student, this feasible solution is a subset that satisfies the given criteria. So I have certain criteria, okay, then the feasible solution must be the subset of that criteria. For example, okay, if I have 80% marks and if I choose engineering, okay, then in engineering, if I go with masters, then if I do the PhD, then when I reach PhD, that is the optimal solution. I must have exact aim where to reach. So the optimal solution is the solution which is the best and most favorable solution in the subset. So I have the subset, right? Okay. What are the subset I have? Medical, non-medical and engineering field. And if I select engineering and if in engineering, if I complete the engineering and if I do the masters and if I go with the doctorate and when I reach doctorate, then it is optimal solution. In the case of feasible, if more than one solution is satisfy the given criteria. So in feasible solution, I'm going to have more solution. Okay, in that I want to pick the best one. When I pick best one, that is my optimal solution, and all the solutions are nothing but the feasible solution. Okay, fine. See, let me to consider this example. I have the example, I have source and I have destination. I want to reach destination, okay, through the intermediate node or through the intermediate vertex. Now, see here, if I go through this way, what is the weight? I have 20. Okay, fine. If I go through this way, what is the weight? I have 10. If I go through like this, then what is the weight? I have 5. So, which is the best route used to reach from source to destination? That is the 5. So, it is minimum cost. So, when I consider optimal solution, I can consider either maximum or minimum. And most of the time, I'll consider the minimum cost. So, I'm going to travel through this direction. So, what's my cost here? It is 5. Okay, fine. Now, okay, where I can able to use greedy technique. Now, the greedy technique is used to find the shortest path. Under greedy technique, we have Kruskal's algorithm, we have Prime's algorithm. So, these are the algorithm used to find the shortest distance or shortest path. At the same time, it is used to find the minimum spanning tree. Okay, minimum spanning tree, that is nothing but using Prime's algorithm or the Kruskal's algorithm. And it's also used in the job sequencing with the deadline. This algorithm is also used to solve the fractional knapsack problems. So these are the certain area we use greedy technique, especially which are the fields, job sequencing, knapsack problem, even Kruskal's problem, Prim's problems, we use greedy technique. Now, under greedy technique, we are going to study about Prim's algorithm. So, what is a Prim's algorithm? See here, the algorithm starts with an empty spanning tree. So, an algorithm may start with the empty spanning tree. So, what is spanning tree? There is no cycle, there is no loop. See here, think that, okay, this is my vertex A, vertex B, vertex C and vertex D. Okay, if I consider it's a cycle, right? It's a loop. Okay, this is not my spanning tree, it's a graph. Okay, fine. Then what about spanning tree? Spanning tree is nothing but the subset of the graph. Okay, in a graph, I'm going to extract the spanning tree. Okay, fine. If I want to draw the spanning tree, how? From A, it is B, and from B, D, and from B, it is C. Okay, fine. If I see this one, this is the example for spanning tree. There is no cycle, there is no loop. Okay, fine. Then what are the criteria I want to follow? That is, in spanning tree, all the edges must be connected. See, how many vertex I have? 4 vertex and all the vertexes are connected. Okay, fine. Then if I consider edge, that is vertex minus 1. So what is vertex? 4 vertex. 4 vertex minus 1, it is 3. Now if I consider the edge, that is nothing but if I count the edge, 1, 2 and 3. So what is the count of the edge? There are 3. Okay, fine. Now there is to maintain 2 subset of vertex. So what I want to do? I want to maintain 2 sets of vertex. I want to maintain 2 sets of vertex. The first set contains vertices already included in the minimum spanning tree. So this is my minimum spanning tree. Okay, first what I will do, I'll create 2 set of vertices. So I'll create 2 set of vertices, okay, that must be already included in my minimum spanning tree. And order set contains the vertices not yet included. So while applying Prim's algorithm, okay, so what I want to do, I want to create the 2 vertex set. In one vertex set, I'm going to have the minimum spanning tree, and in another vertex, okay, which one I'm not yet included, that one I'm going to place. Now, at every step, it consider all the edges that connected the 2 set and pick the minimum weight edge of these edge. Okay, fine. See here, this is my minimum spanning tree, A, B, C. This is my A, B, C, D. Okay, fine. If I consider the weight, 2, 5 and 1. And I have E. Okay, fine. It is 3. Okay, fine. If I consider I have the weight 2, 5 and 1. To reach A to D, what is the weight? Minimum weight I am considering 1. So here, it consider all the edges. How many edges? 3 edges. In that, how I am going to select the edge? I am going to consider the minimum cost. So, I am going to pick the minimum weight edge. After picking the edge, it moves the other end point of the edge to the set containing minimum spanning tree. Okay, fine. From D, okay, is there any possibility to reach E? Yes, I have only one possibility, that is 3. Okay, I want to select the next edge to reach next vertex. Okay, fine. Now, let's see how the algorithm is going to work. First, what I want to do in my step 1, okay, determine the arbitrary vertex as the starting vertex of the minimum spanning tree. In the given graph, okay, I want to determine from which vertex I'm going to start my travel, okay, starting point. There are certain time in the question, they're going to provide which is the starting point. If they didn't mention anything, randomly you can able to select the starting point. So in step 2, follow step 3 and 5 till, okay, till vertex that are not included in the minimum spanning tree. So I want to repeat the steps until unless I'm going to include all the vertex. So find the edge connecting any tree vertex. So I want to find the edge in such a way that it's connecting to the tree. Okay. Now find the minimum among the edge. If I have 2 to 3 edge that are connecting, in that I want to pick the minimum cost. So minimum cost I want to pick, then add the chosen edge. So what I want to do? I want to add the chosen edge to the minimum spanning tree. Okay. In a given tree, what I will do? I'll construct the minimum spanning tree if it does not form any cycle. So in my spanning tree, I cannot have the cycle or I cannot have any looping. Return the minimum spanning tree and exit. So these are the steps I want to follow while applying Prim's algorithm. Okay, fine. Now let me to take the example and trace the example. Okay, fine. See here, this is the example. Okay, I'm going to have the Prim's algorithm. See here, this is my tree. Okay, this is my tree. Now, if I consider this much, it's a cycle, right? All the vertices are connected each other. It's a cycle. Tree can have the cycle, but my spanning tree cannot have the cycle. So it is my tree. Okay, fine. If I consider 0 is my starting point, from 0, okay, to reach 1, what's the weight? I'm going to have 4. And from 0, if I want to reach 7, what is the weight I'm having? It is 8. Now, if I consider 4 and 8, which is the smallest one? 4. I'm going to consider the weight 4. Anyway, let's solve this example. Okay, in my first step, what is my starting point? The starting point is 0. So arbitrarily, I'm going to select the vertex. And what is my starting point here? I'll select 0 as my starting point. Now, in my step 2, see all the edges connecting in incomplete minimum spanning tree and other vertices are the edges. So here, if I consider, I'll write 0 to 1. Okay, what is the weight I'm going to have? The weight is 4. And if I consider 0 to 7, what is the weight? That is 8. Now, okay, which one I'll select? I'll select the weight, that is 4. So what is my root here? I'll select the root, this one. Okay, which is my root here? That is 0 to 1. Okay, fine. Now, see here, if I consider 1 in my next step, okay, fine. See, I have connected, okay, I have chosen the minimum value 4. So 0 to 1 is over. Now, if I consider 1, okay, from 1, I can able to reach 2 and at the same time, okay, I can able to reach 7. I can able to reach 7. But if I consider previous one, I have 8. Okay, now see here, here also I have 8. Here also I have 8. So what I will do? I'll go with this. So what is my spanning tree now? 0 to 1 is over with the weight 4 and it is, okay, 7. 0 to 7 with the weight 8. So how I'll select 0 to 7 with the weight 8. Okay, fine. So this much is done. Now remaining, okay, I want to find the minimum spanning tree. Now I want to construct the minimum spanning tree. So here the edges connecting the incomplete. So this is the incomplete, okay, minimum spanning tree to other vertex. So 0 to 7 I have 8. Next 1 to, that is 1 to 7 I have the weight 11, and 1 to 2 I have the weight 8. Now let us here include the edge 0 to 7. So I'll consider the edge 0 to 7 in my, that is minimum spanning tree. That's nothing but the MST. Let's go to the step 4. Okay, fine. Now if I consider 0 to 1 is over and 0 to 7 is also done. Now if I consider 7, from 7 I can able to reach 6 and 8, okay, with the weight 1 and 7. And if I consider 1, okay, that is I can have 8 to reach 2. But if I consider this one, which is the minimum weight I'm going to have the weight 1. So what is my tree now? Spanning tree, that is 0 to 1. Okay, from 1 it is 7, from 7 it is 6. From 7 it is 6. So I have 7 to 6, I have the weight 1. Now if I go to step 5, see here, this much is over, this much up to 6 is over. Now if I start from 6, I have the weight 6, and to reach 5 I have the weight 2, which is my minimum weight 2. Now okay, I'll consider the 2 because 6 is highest weight, right? So I'm going to ignore 6. I'll consider the minimum weight 2. Now the spanning tree is this much. Okay, my spanning tree is till this. I'm going to have my minimum spanning tree. Now okay, in my step 6, see here, if I consider 5, I have 3 possibility. That is, I can able to reach from 5 to 2 with the help 4. Okay, if I consider 5 to 3, what's the weight? 14. 5 to 4, what is the weight? It is 10. So among the current connection, that is current connecting edge, the edge 5 and 2, I'm going to connect 5 and 2. Okay, so I'm going to connect this one and this one with the minimum weight 4. Now this much is my spanning tree. Moving to step 8, see here, okay, see here, if I consider 8, that is 7 to 8, so what is the weight? 7. And if I consider 2 to 3, what is the weight I have? That is 7. Now, okay, in that I'll consider 2 to 3. But 7 is already, see, this 7, it is already the part of the minimum spanning tree. Fine. Now, which is left out? 3. 3 is remaining. Now, I want to include this 3 as my part of spanning tree. In the sense what? In my spanning tree, I must include all the vertex. Okay, fine. So, what I will do, I'll consider 2 to 3 with the weight 7. With the weight 7. In my step 9, see here, only one vertex is remaining, that is 4. Vertex number 4. And I have only one possibility to reach vertex 4, that is with the help of weight 9. So, I'll reach vertex 4, that is 3, 4 with the weight 9. So, the minimum weighted edge from minimum spanning tree to other vertex, that is 3 to 4, that is the weight 9. Okay, fine. Let's see the final minimum spanning tree. So, how I started? 0 to 1 with the minimum weight, that is 4. Now, from 0 to 7, it is 8. From 7 to 6, the weight is 1. Now, 4 to 5, the weight is 2. From 5 to 6, the weight is 4. And 2 to 8, the weight is 2. And 2 to 3, the weight is 7. And from 3 to 4, the weight is 9. And if I consider, it's a minimum spanning tree. So now let me to count how many vertex I have. That is 0, 1, then 2, 3, 4, after that 5, 6, 7 and 8. So 0 to 8, there are 9 vertex. 0 to 8, there are 9 vertex. Okay, fine. Then if 9 vertex, then how many edge I must have? That is, okay, 9 minus 1, that is 8 edges. So 1 edge, 2, 3, 4, 5, 6, 7 and 8. So 8 edge. So it's a minimum spanning tree and it satisfies all the properties of spanning tree. So this is all about Prim's algorithm. Anyway, let's meet in the next session with more information about greedy technique. Until that, keep watching and keep learning. Thank you.